I bought this meter back in the early 90s. I do know that I blew it up, and specifically it blew up the chip here. Reconfirmed that this hybrid module, the SDG HD03R, is the one that's faulty. In taking some photographs, I bent the chip and the damn thing broke most of the leads. Completely removed the module. Used some acetone, glass jar, some sort of sealant on the lid. Take that chip off, drop it in the base of the glass container, and just let it sit there. Left it in there for 3 days. Then try to reverse engineer the circuit. So it's been in there for about 6 hours now, and might be able to see that there's a slight tinge to the water. There's a tiny bit of debris in there, but interestingly enough, side on, and I've taken some camera. I need to move the video camera, but there's two things. It's a thudding sound now instead of a tinking, hard, so it's obviously softened, but the top half of the module is bubbled out. So on the two ends, on this end and this end, it's bulging. Okay, so this is about 10 hours now. You can start to see where those, well, you can't see that, I'll take still photos. You can just start to see some white board in there. Okay, so it's been about 24 hours, and I think I'm going to pull it out. The acetone is evaporated quite a bit, and that probably happened last night when I was trying to do some recording, just of progress around about the 10-hour mark. I turned the bottle on its side, and then I started to notice a hissing sound, and then realised it seeped out underneath. So I haven't actually had this lid off since then, but I think it's done well enough now that I should be able to get the most part of that epoxy. Because what it looks like is the outer part of the epoxy looks to be still sort of intact. You can see the writing on it, but it's split where the boards, probably where the epoxy was the thinnest, and it's separated, and there's a white. So I'm presuming that the printed circuit board is one of those ceramic ones. So I got my eye protection on, so let's see what it's done to the lid. It's not too bad. So it was just probably a little bit maybe slipped in under the lid there. So put the lid back on again. So it's popped a little bit on that edge here as well. So it's peeled away from the back part of the board, and as you can just see, there's a little pocket on one of the ICs there. On the larger package, that little thing there. Very rubbery. So almost about having like a heat shrink or something like that. And let it break on this end. Yeah, so it's the ceramic underlayer, ceramic PCB. Okay, so it's burst on the top of that chip. Alright, so I could do with a bit more soaking, but you can definitely see an IC. Putting a little bit of pressure on there. The main thing is I don't want to rip any components off. And if I can, as much as possible, I'm going to try and get it off in one piece. That way it's easy to see if I've ripped anything off, any components off. Hopefully that big chip isn't a microcontroller or anything like that. So much for the plan. So there's a little switching device, probably a transistor. So I should be able to read that. MJU 4030B. That's testing my memory. So it's probably one of the CMOS 4000 series 4030, which comes up as a quad exclusive OR gate. So it should be 14 pin package. 1, 2, 3, 4, 5, 6, 7. Yeah, so that'd be an exclusive OR gate. Oh, it's got printed resistors. Carbon resistors. Alright, I'm going to soak that up again. Continuing on from where we were before, I've left it. Well, actually, I've neglected it. It's been in there for probably 1.5 days now. So it should have been yesterday that I looked at it, but it's this morning. Anyway, so it's evaporated quite a bit since then. And the acetone has evaporated quite a bit since then. There's the leftovers from before. So now I want to use something to pick away at it that's not going to be damaging, so I'm try using a toothpick. So, there's our board. No circuitry on the back, so it's single-sided. And what we now need to do is we need to trace the circuitry out. I actually just pull this off using my gas hot air tool. Got my replacement CD4030s surface mounts for the Metex. What have we got in the shop? Yeah, okay. So it's just a matter of mounting it. So if I've cleaned all of these pads reasonably, pin number 1 is over here. and so just a matter of mounting these to. That's the new module. Okay, so I've got my little magnifying glass here, and I've even these things that are like cheapy, the glass is just big enough for me at from a distance to keep both eyes open and effectively get a 3D capability. In theory, I should solder the ground planes and stuff like the power first. Feels a bit uneven. I still probably got some crap from the epoxy. This crap here. Yeah, I'm at a slight disadvantage here because I can't actually see it properly. But let's just solder one of the pins in first and then straighten it. Just using leaded solder. Get by with the chisel. Oh shit, if the bloody pads come off. That'll teach me. Alright, use the hot air tool. Sorry about that. I started heating it up and didn't realise that I had neither the camera in the item in shot, nor did I have the recording right. So yeah, didn't place the chip properly. When I realised halfway through, and I think the solder melted. That'll learn you. Oh well. Break the pad on there as well. So now it's a matter of just cleaning up. I've wrecked that pad and that pad, and some of the other pads have got a little bit messed up as well. And because my soldering iron was too hot, and I'm changing the tip to a smaller one. Alright, so let's see if I can fix this up with all these big bits that I've got. This is about the smallest bit I've got. I should invest. Alright, so I'm going to put a bridge between those two pins there. So I've wrecked the pad there, so that's fine. Some fixes around the lifted pads, so I've got the insulation off. Okay, so the module is being repaired, so to speak. Turned out to be much more difficult than I thought. This is I've never actually repaired a hybrid module before. At least I don't recall repairing one before. And the takeaway is you're a bitch. I had to use a really fine tip on my soldering iron, and it doesn't quite have the right, the thermal transfer I was expecting. So I turned the temperature up a bit, and the ceramic board didn't like it. When I tried to, when I got the IC off, that was fine. When I cleaned it with some solder wick, that was fine. But when I went to start to place the replacement chip, I didn't have any solder paste. And silly me, I pushed on. I just went to go use ordinary solder. Therein lied the problem. As soon as I started using ordinary solder, I had to turn the temperature up. I think I turned it up to about 330, 350 degrees Celsius. And I would solder, you'd see the solder go down, and you think, great, and you pull your soldering line away, and you start to notice, hang on, the pad's gone. Thus, the monstrosity you see in front of you. So, I have encountered it, but I'd be surprised if there was more than 50% of the original connections. The tracks are still in place. It's just that when they get to the pad of the IC, they've lifted. So, yes. On this particular module, I've put some Estopole on it. I was going to go look for some replacement pins here. These are just soldered on to the board, but I thought I'm going to leave it alone because I've already ripped off enough pads as it is. So what I'm just going to do is I'm just going to feed in some wire wire similar to what I've got here. This is all one type of wire. I should actually find out what gauge it is. I think it's 30 gauge. So some of them have still got the insulation on, others I just stripped the insulation off. So these are easy, just have to strip the insulation off. All these connections in between here, the pads. What suppose one of the important pads that was a rip-off was the power going in here, so I've just put a big solder blob on there. And I don't have the appropriate flux to do solder work on this sort of thing. The only flux I've got to hand is this stuff, and this is what you need is a gel type flux to do soldering iron work with this sort of surface mount components. Otherwise the solder just doesn't stay wet and you get lots of dry joints. So it doesn't look the best, but we shall push on. So what I'm going to do is I'm just going to put some solder in the hole, stand it up this way, and then feed that through the lead like that for each of the... So I just need to get some solder in those holes to begin with. We'll see whether that's a bad decision or not. There is one that's already got a pin that's stuck in the hole, so I might just push that in. Basically I've just fed the wires through and now it's a matter of attaching them to the modules on this side. So the trick is I'm just going to flood it with solder and let the that wire act as a guide, as a stabilizer for the solder. It's a connection of some kind. It's not exactly the prettiest, but so they're all looking okay. Well, look like there's electrical connection. They don't look very good. So well, let's get that back together and see what happens. Damn it, I need to move it over. Okay, so that's moved over quite a bit now, and it's now a matter of cleaning up this gunk on the side here, which I put on to do that experiment. So I'm sorry about that though. I forgot to record. Basically what I did was just bend that back out. I've mounted that and then remembered I needed to fix that cut track, which I've done, and I've just cleaned the flux and crap off there, and it's a little bit skew if... Let's see what happens. Fingers crossed. Fingers crossed. Whoa, baby! Okay, so we got some indicators. So why have we got milli on all the time? We're getting some dodgy ones coming up when they shouldn't be. So the problems now won't be this module. It'll be like pull-up resistors and stuff like that now. We've got stuff staying on when they shouldn't be on. Actually, that's the point. Just move the display around. That's fixed it straight away. So it's just a mechanical issue now. Like I bought one. Still a little bit of an issue with the HFE on this side, but sweet. Okay, so I've moved it over a little bit more, resoldered these connections here just to remove any stress of the solder joints. It is hard up against the module, but hitting each of those joints successively should relieve the stress on those, and that's pretty much fixed it. So it was just a mechanical issue. So now that the module's fixed with the right signals, it's just a mechanical issue. It's all working fine. The right indicators are coming up, decimal points. And when I turn it off, the battery indicator comes on, like that. Sweet. Okay, before I go on the calibration, let me just make sure it is repaired properly. Alright, that's cool. 2 milliamps. Yeah, when that module was faulty, it was I can't remember, but it was a lot more than that. Probably a magnitude, order of magnitude greater than that. And it might have been in continuity test when I did that. And capacitance check. I thought I'd see how much current we're drawing. 5 milliamps. Yeah, it's not too bad. I mean, it's only like 5 milliamps. Adjustable power supply. Into the meter. Leave it on capacitance range. We'll see what voltage the battery kicks in. It's a bit damn high. So that's part of that transistor circuit. That's on that thing that got fixed. Let's assume that this battery is not going to fluctuate with this load. So whatever reading we get, and then I'll drop the voltage. The indicators come on, the voltage is still. Alright, so that's where it's going there. So around about 6 volts. About 6.9 volts. So there's a bit more headroom there, but that would require me to change the circuit, probably change that transistor. I'm not going to worry about it.